This is Mr. Anderson for Keller Community College. We're going to be doing the last 4 problems on this worksheet here where we're going to be solving rational equations. And the difference between the first 8 and these last 4 is that these last 4 problems have more than one radical in them. Now the strategy for doing this is to have one radical on either side of the equal sign. It's not going to actually be useful to us to have both radicals on one side because of the technique I'm going to use right now, which is to square both of these. Now the right-hand side kind of turns into what I kind of wanted to do, which becomes the square of the square root of x plus 9, which is just x plus 9. But watch the left-hand side. This turns into a FOIL problem. So this 3 plus the square root of x minus 6, well, that is going to have to get FOILed. And that is going to become somewhat tricky at times. So 3 times 3 is going to be 9. 3 times x minus 6 is going to be 3x minus 6. And then this here, this inside cable, is going to be 3x minus 6. And then this last cable here, these two multiply together, since this is kind of the same thing, because, we're multiplying this to the 1/2 power times this to the 1/2 power, it's going to raise it to the first power. So this square root of x minus 6 and this square root of x minus 6 will become just x minus 6. And this is equal to the x plus 9 on the other side. What I'm going to have to do is now take this side and simplify it. So 9 minus 6 is going to be 3 plus x, and then here I've got 3x minus 6 plus 3 square root of x minus 6 is going to make 6 square root of x minus 6. And that's equal to x plus 9 on the other side. Let's move everything over to one side now. So I subtract the x's, and what happens there, something nice, these do simplify. Subtract the 3's. So now what I have is 6, and then I've got x minus 6 is equal to 9 minus 3, which is 6. If I divide both sides by 6, I get x, the square root of x minus 6 is equal to 1. I'm going to rewrite this over here and kind of encroach a little bit on my room there. X minus 6 is equal to 1. If I square both sides to get rid of the square root, I got x minus 6 equals 1, because 1 squared is 1. Then I move the 6 over to the other side, so I've got x is equal to 7. Now it's important that when I get my answer, or answers, as the case may be, I have to go check that back into the problem. Now, if I take a look at that from the original here, 3 plus 7 minus 1, which really becomes 3 plus the square root of 1, which is 1, is that equal to 7 plus 9, or the square root of 16, which is 4? And so this checks out. So to review, what you have to do is you have to get a radical on either side of the equal sign. You square it, and then you do your FOIL on one side, and on the other side you simplify it, and then just solve for x as best as you can. The next problem, problem 10, is going to be a rather involved problem. So you may need a separate piece of paper for this. When I'm done, the work is probably going to extend to the bottom of the screen, and I'll have to erase it to try to do the rest of problems 11 and 12. So just letting you know, a little bit of a warning, you're going to need a lot of room for this. Now, the way that this is set up is not to our liking. We have to get a radical on both sides of the equal sign. So I'm going to move this second term to the right-hand side. So this becomes 6x plus 7 is equal to 1 plus the square root of 3x plus 3. We're going to square both sides, which is going to mean that my right-hand side is going to get FOILed. So instead of putting a little 2 by it, I'm just going to write it twice to save myself the time. of doing it later. Now my left-hand side is going to become 6x plus 7, and we're going to ignore that for a while because now we have this to FOIL. 1 times 1 is 1. 1 times square root of 3x plus 3 is square root of 3x plus 3. 1 times the square root of 3x plus 3 is the square root of 3x plus 3. And then the square root of 3x plus 3 and the square root of 3x plus 3 is going to be, when you multiply this last cable together, it will just be 3x plus 3, because a half power and a half power make a total of 1 power, so it just all comes out. The 1 and the 3 make a total of 4. The 3x stays outside because here it is, and this is going to make 2, and then the quantity of 3x plus 3 under the square root. Now let's move these to the left-hand side. If I subtract the 4 from the 7, that gives me 3. If I subtract the 3x from this side, this gives me 3x plus 3 is now on my left-hand side, and my right-hand side is now 2 times the quantity of 3x plus 3. Now, at this moment, what I'm going to do is square both sides. I'm going to square both sides because this will get rid of my radical over here. Now over here, I will then have to FOIL the 3x plus 3 with another 3x plus 3. That's what squaring means. It means you have to FOIL it. So this will become 9x squared plus 9x plus 9x plus 9. And over here I have 4 times the quantity of 3x plus 3. If I square the two, this can jump to the inside because these are two separate things. 2 squared is 4, and the square root of x squared plus 3 squared is 3x plus 3. All right, let's simplify this over here on the left-hand side. 9x squared plus 18x plus 9 is equal to 12x plus 12. I'm going to move everything to the left-hand side here. So this is going to become 9x squared minus, let's see here, that is going to be, plus 6x, and move this over here to the other side. This is going to be, let's see here, minus 3 equals 0. Now we have to factor this. Now I think one of the best things to do, the first rule of factoring, is to factor out a common term, which is going to be 3. So I get 3x squared plus 2x minus 1 equals 0. Now I've got to figure out how to do this tricky trinomial. I'm going to multiply this by this and get negative 3 to think, now what two numbers can I split this into to make a negative 3? Well, that's going to be negative 3x and positive 1x. Will that be the other way around? Here, let me look at this here. I think that is going to be a positive 3x and a negative 1x, because that is how I get my multiplying 3 times this, 3 times negative 1 to get negative 3, and that gives me the positive 2 in the middle. So I split this up into my 4 terms like I did back in chapter 5. There's still a 3 on the outside here. Some people have probably already gotten rid of it because you can divide both sides by 3. So 3 times the quantity, let's factor this into groups here. Factoring out a 3 here, which gives me 3x, which gives me an x minus 1. And I factor out a negative 1 here, which gives me my x. Oh, that should be a plus 1 there. X plus 1. So now I've got my x plus 1s to know I did the problem right. So x plus 1 is one group, and my 3x minus 1 is another group. My 3 is still on the outside, and that's equal to 0. So now I can take my two parts here and solve for x. X plus 1 equals 0. 3x minus 1 equals 0. So x equals negative 1. Move this over to the other side. 3x equals 1. Divide both sides by 3. X equals 1/3. So now I have to check my answers. Now, I got my two answers, negative 1 and positive 1/3. It's best to use a graphing calculator for this. So in my check, I will now go to my graphing calculator. Now remember, what I'm checking is to see in problem 10 if my answers of 1/3 and negative 1 actually work. So let me take my square root here. So this is the square root of 6 times 1/3, because remember that was one of my two answers, plus 7 minus, let's do the next square root here, 3 parentheses 1/3 plus 3. And let's see what this adds up to. 1. So my 1/3 checks. Now I'm going to check to see if plugging in a negative 1, so changing all of these to negative 1s, gives me the same answer. Have to use my insert and delete functions here. You can retype the rest of the problem if you'd like, but this is just a quicker way to do it. Alright, whoops, get my calc back here. Okay, and hit enter. So both answers in this problem, both answers for number 10, solves the problem. Now, when we move on to, let me move this down here a little bit. When we move on to 11, there is a typo on the worksheet, so you'll want to change this if you have an old copy. This should be a negative 1. Okay, I've just saved it for the future, but in case you have an old version of the worksheet, you should change that to a 1. Alright, now let's go and do the problem. This is going to be, if f of t is equal to this, find any t for which f of t is equal to 1. So this is saying, alright, so f of t is equal to this, and f of t is equal to negative 1. Through the transitive property, we will have to set up where this equation is equal to this. So let's start that out by going the square root of 2t plus 7 minus the square root of t plus 15 is equal to negative 1. Now, the goal here is to get one of these to the other side. So here I'm going to have my square root of 2t plus 7 is equal to negative 1 plus, instead of minus since I moved that over, the square root of t plus 15. We're now going to square both sides, which means that this has to get FOILed. So I'm going to write it twice to save me a step from the problem. So this becomes 2t plus 7, because the square root of something squared is itself. Negative 1 and negative 1 make positive 1. Negative 1 and this make negative square root of t plus 15. Negative in this is another negative square root of t plus 15. And then finally, if I square this and this is going to be just t plus 15. I'm going to simplify. The 2t plus 7 is equal to, let's see, 1 and 15 make 16. The t just is t. And then this becomes negative 2 square root t plus 15. Move this to the other side, so we have t. Move this to the other side, so we have, let's see here, just checking my work here, negative 9 is equal to negative 2, and then t plus 15. So now what we have to do is square both sides. Now if I square both sides, that's going to make my t minus 9 quantity squared. And if I square this side, this is going to be negative 2, and then t plus 15 quantity squared. The t minus 9 squared is going to be t squared, and I'm going to do this in my head, minus 18t plus 81. And this is equal to 4 times the parenthesis t plus 15. This is 4, then the letter t, plus 15. 4 times 15 is going to be 60. And still over here on the left-hand side, t squared minus 8t plus 81. Subtract the 60 from both sides, and that is going to make a positive 21. Subtract the 4t from both sides, and we get a negative let's see here, negative 22. Just checking my work. Now, the nice thing about this is we can easily factor this. Two numbers that multiply to make 21 and add to make negative 22 is t minus 21 and t minus 1. Because that makes a negative 22 when you add those together and they multiply to make the 21. So my answers are 21 and 1. Now, I'm going to go back and check these answers. Now, when I do so, all this is going to get erased. So I'm checking to see if 21 and 1 will make the problem true. So let's go and check it out on the calculator. Fastest way to do it. So I'm going to try 21 first. Okay, to do so, I'm going to go the square root of 2 times 21 plus 7 minus the square root of 21 plus 15. And that gives me an answer of positive 1. So 21 is not an answer to my problem. Let's try and see if my second answer, which we found 1, let's see if that is an answer. Let me delete the 2 there and the 2 here. And there it is. So even though we found 2 answers to our problem, 1 and 21, only one of them works. And the only one that works is going to be that number, the 1. Okay, so for our final problem here, okay, so here we go for our final problem. Can't move down any further. This is going to take up a lot of room. So here we have f of t is equal to g of t. So I'm going to plug these two equal to each other. Now I'm going to square both sides, which means that I'll have to do this twice. Just doing this to save myself some time. And I'm going to square this here. So this is going to be 49. Forgot my little square root there. And this is going to be plus 7 2t minus 5 and another 7 square root of 2t minus 5. So it's going to be 14 square root of 2t minus 5. And many of you knew that pattern already, but I just wanted to do that for speed's sake. Then plus 2t minus 5, because the square root and square root multiplied together gives you the term on the inside. And this is going to be 9 parentheses t plus 1. So simplifying this over here, I've got 2t and I've got plus 44 plus 14 times the square root of 2t minus 5 is equal to 9t plus the letter 9, or the number 9. Let's move everything to the left-hand side here that we can, except for the radical here, which is going to be 7t, and then moving this over here is going to be minus 35. Now, a clever technique, if you take a look at 14, 7, and 35, and this might not be visible to most people here, but if you take a look at this problem, you'll notice that your 14, 7, and 35 are all divisible by 7. So in kind of a neat little trick here, I can divide all of these by 7, which will give me 2, and then 2t minus 5 is equal to t minus 5. That's going to make things a lot easier when I go to my next step, which is squaring both sides. And I think without actually seeing that in the problem, most people would have missed that. So I'm going to square this, which means I have to write this twice because I'm squaring both sides. So this becomes 4, and then this becomes 2t minus 5 is equal to t squared minus 10t plus 25. So this is 8t minus 20 is equal to t squared minus 10t plus 25. I'm going to move the 20 and the 8 to the other side. So this is t squared. If I move that, this is negative 18t. And since this is a plus 25 minus, now adding the 20, this is plus 45. So I ask you this question. Are there two numbers that multiply to make 45 and add to make a negative 18? And there is. A negative 3 and a negative 15. This makes the two numbers I need. So these two numbers multiply to make positive 45. The negative 3 and the negative 15 add to make negative 18. So I'm going to take my t is going to be equal to 3. My t is going to be equal to 15. Now I'm going to tell you that one of these numbers, even though we found these two numbers to be the same, guess what? One of these numbers is not going to be our answer. So to go check this on the calculator, I'm going to have to click off this screen, which unfortunately is going to erase everything we've done. So make sure you pause this and copy down what you need. And let's go check our answer. Okay, we type in to our calculator, we're going to type in 3 and 15. So let's try on the left-hand side here, 7 plus the square root of 2 times 3 minus 5. All right, 8. Now let's try it on this side. 3 times the square root of 3 plus 1, and we get an answer of, looks like 3, even though it came out as one of my answers, is not one of the correct answers to the problem. So 3, even though we found it, does not work. Let's go try again, but instead of trying the 3, let's try the 15. Using my insert command. Okay, I get 12. Now let's go get my previous equation up here. Okay, typing in 15 to see if it will work. And 12. So our answer for problem number 12 is 15. This is our only solution. Even though we got two answers, we had to check to see which one was correct. All right, well, thank you for watching.